Hello. I feel like I'm a teacher or something. It's really, really disturbing. Hi, everyone. Thank you very much for coming today. I don't know if you're here for the talk or because you have plugs where you can charge your laptops, but I'm going to go for the first one and hope for the best. Anyway, thank you very much for being here. We're going to talk, and I've got 35 minutes, and it's a very short time to demo everything I'm going to demo. So sorry if I rush a bit. Don't hesitate to come back afterwards and actually ask any questions. I'd be pleased to fill you out for any problems. Right, so we're going to talk about chaos engineering. I don't know if you're familiar with the term or if you practice or if you're familiar with chaos engineering in general. If you're not, I'm not going to dwell too much. You see all those slides on left. I'm not going to go through that. It's going to be a demo session. But the slides are for you to actually go after the fact if you want. But there are many other resources for actually theory around chaos engineering. Suffice to say that what we're going to agree on today is chaos engineering is not necessarily break or not break. It's more about collecting data to see if you have weakness in your system. And collecting data in an automated fashion to see how your tooling already, like tracing, like monitoring, can help you out figuring out if you have weaknesses in your system, and you probably don't realize that. So we're going to do a demo. Sweet, let's get rid of the slides. Okay, so it's really tricky when you have a big screen like that and you've got so many windows to show, but let's hope for the best. Right, so where do we start? We've got a very, very stupid, simple service that returns when we talk to it. I think that's the one. That when you talk to it, it simply returns a payload that says, the version of the service running, the timestamp of the call, and the number of calls that is received so far. So that's it. That's just the endpoint that we're talking to. I kept the simple thing because I wanted to focus on the chaos part, not on the service side. Right, so we've got that service, and we see that we have just one pod for it at the top. Now, because we are very, modern and everything, we want to go to microservice, sort of architecture, and we decide that service shouldn't be actually the one generating the number. It should be talking to another service somewhere, however it does it, and return the value. So we're going to have a second service doing that we're going to deploy, on our side here on the left side. So service 2 now is actually generating data for us, and we're going to see that. And we're seeing on the bottom right that service 2 is responding and generating a number. But so far, we see service 1 is not still talking to service 2, it's still generating its own. At that stage, we're like, okay, we're going to roll out a new version of service 1 and see what happens, right? And that's what we're going to focus on today, on that specific just command of rolling out a new version of service. I'm sure if I ask you what's going to happen, you're going to say, well, I know it's going to go well, right? Either because Kubernetes does that for me, pays attention. If you're not familiar with how Kubernetes does that, we'll see that in a minute, but it's going to start a new pod with a new version, and if the else probe, is fine, it's going to switch to that new version, and it's all good. But what you think is actually assumption. You assume it's going to go fine. First of all, you don't know in all circumstances it's going to go fine. And more to the point is you don't know what the impact is if it doesn't go well. And that's what chaos engineering is all about, is saying we're going to purposefully try in various scenarios that can be dire or very good and see and collect data as we do so that we figure out and we can make an analysis after that of, well, what really happens. So we collect data so that we have evidence about the impact on the system on a simple command that is, changing the image of a pod somewhere. So in this very simple setup, we're going to actually do that, and we're going to have, let me see, yes. So hang on, I'll increase a bit this one, if I can. Yeah, I should be fine. All right, so we're going to see what that can look like, but I'm going to explain first one thing. Chaos engineering, for a lot of people, we were just discussing that, is quite often just chaos monkey. You run, break stuff, and you're happy. Well, that's one way of doing it, no doubt. But it's more a protocol. If you break something or you change something in your system without even breaking it, but you don't have an idea of what you need to collect to analyze after the fact, you'll know better than if you didn't break anything. because you don't know what to look for. You don't know what to read in your system. You just broke something. And maybe you were in front of the system at that time, and maybe you're not. And maybe you're not even looking at the right thing. So the protocol that Chaos Toolkit, an open source tool that we're going to demo today, is trying to come up with is say, well, we're going to have actually a scientist approach here. We're going to say we have actions that will impact the system, not necessarily breaking or damaging the system, but simply doing something to the system. And we're going to have probe that will simply collect data as we do so. Because we do that in one package, at the end of the day, we have a lot of data that we can generate a report and analyze from. But at that stage, you still haven't actually checked if you're in the right. The whole idea of chaos engineering is to start from an hypothesis, your question. If I do this, if I do a rollout of a version that is safe, what should I see? I should expect that service 1 is deployed and service 2 is deployed and service 1 is happy bunny. But what if, for example, you think, okay, what happens if I release a new version that is unhealthy? You probably don't know. What if you release something that has latency? Now service 2 is responding, it's all fine, your testing was fine, it's all green. Functionally it's working, but maybe your system is unhealthy for it. Because it's slower, and you don't necessarily know how fast service 1 is expecting your response for service 2, it's not happy. So you see just that little command of rolling out a new version already starts expanding into lots of questions, and those questions should be turned into experiments. And honestly, they just look like a bunch of declarations that I'm going to demo here, that you can run automatically. So what does this look like? All right, we're going to go for the method. It's a bit, over the top, perhaps the naming, but the method is basically a bunch of actions or probe that you're going to run to change the system. So here we're going to say, and I'm going to show you one, it's a probe saying, well, I'm going to run, it's a Python thing running in the background, it doesn't really matter. So we're going to run that thing that is called set deployment image, and we say for the deployment service 2, release version 1. And that's going to be our null hypothesis, I'll explain that later. What we'll do after that is we're going to run some load test. Doesn't have to be high impact, just something that you casually run against your system. So here, this one is going to simply talk to the system every 3 seconds for 20 seconds, something like that. At the end, here we have a probe. That probe is simply collecting data. Here we're going to look at the Kubernetes pod status, or deployment status actually, and that will tell us whether or not we actually shift it or not, change the image. So all the data is there, but you need to collect it as you run, otherwise you can't actually compare or correlate. Sorry, I might, if I remember the command. Yay, is that better? You're welcome. So we do that, and it doesn't really matter how that looks. Basically, it's always the same idea. Either you run a Python function, or you run a process, or you run an HTTP endpoint. It doesn't really matter. You could go, other things. Suffice to say is you run that sequentially, and you look at what happens. But now at that stage, you still have the method, and the method is telling you what you do to the system and what you collect, but you don't have actually checked anything. And that's what you do in that block called steady state. Here, what you do is you define a set of probes again, and you're going to say, I'm going to query my system for that. And that system is going to just simply talk to my monitoring tool and say, did I see any 500 errors from the service 1? Now, usually what you would want here is not something too technical. That's a demo, that's a bit low level. You would want your SLO there. Because you really want to know from chaos engineering, have I impacted my users? Have I actually hurt my business? And I mean that in a very friendly sense. Have I hurt my business by doing this? You know already by doing testing that from a technical bit, you know you can roll out that, that's all good. But sometimes you forget about looking from the, very far away and see how your users are impacted by doing that. So usually your things there, your probes are simply, I'm going to talk to my endpoint, something in my system that tell me, am I doing right? Am I looking good for my users? So you collect data in, what you have in addition is a tolerance that's simply, this one is going to go through the JSON returned and look for a bit of data. That's it. And this one is going to say, for the last 10 seconds, I didn't see any, 500. Now, that thing is interesting in itself, but it runs twice, and that's what makes it very interesting overall for chaos engineering. What it does is, when you start running, it will run the first time before the method and say, before I do any action, am I actually already doing fine? Because if I'm not, there is no point in continuing. I already know I'm broken, or in a state that I can't actually read after the fact. So it will bail on the experiment immediately. The second time it runs is after the method, and basically it will tell you, have I deviated? If I see 500 errors, now, admittedly, you could have errors coming up for all sorts of other reasons. But for the purpose of this demo, we know that the only way you could have that is because of what we've done, right? If you've got errors, then you know that when you do that specific action, when you roll out that version or a specific, in some conditions, you've broken is not really the right word, but you haven't kept your promise towards the user. So chaos engineering is really to collect data, collect evidence that you're doing fine. It doesn't say the bricks are doing fine. You may have actually a service that's broken somewhere. It doesn't really matter. What matters is the whole. It's your system. It's how your users perceive your system. It doesn't really matter if you have actually lost half of your system if you can still provide a sub-service. Right? Let's say I'm Amazon or something like that. Is that okay if people can't buy but can still search for product and put that in their basket? Am I still doing good? So that's the sort of question you're looking for in your system, and chaos engineering is there to collect data towards finding answers toward that. Right. Quickly, because I won't go straight away to that. Quickly here, what time is it? Right. We have got rollbacks. Rollbacks, I just want to go quickly on that. Rollbacks are not about setting, at least in Chaos Toolkit and Chaos Engineering, not to put back your system where it should be. It can't know that, because if you've discovered something you didn't know, how could you actually prevented that anyway, or put it back right? What you do usually is you undo what you've done. So in this one, we simply do a rollback of the version we rolled out, right? That's it. So how does this look? All right. Here we've got service 1, service 2, and there's still happy bunnies. So we need to move service 1 to service 2, actually. Right. So we're going to change the image of this one. So that's a manual rollout. So what we do here, if you look at this one, we see we're changing that version so that suddenly this one will match this one. And we're saying basically version 1 should be talking to, service 1 should be talking to service 2. Obviously, if demo god is with me. Yeah, so now we know that service 1, the one that users see, even though they don't know it's called service 1, but what people talk to is talking to the second service in our backend. Yay, we've got a microservice architecture. So. But is it brittle? Okay. What we're going to do here is going to run that thing that I showed you, the experiment, in a chaos engineering way. And the first one is we're going to say we're going to roll out the same version here that we already have running. Now, what would Kubernetes do for that? Well, it won't actually do anything because the image is the same, so nothing happens. That's our null hypothesis. It says that's our baseline. If already something was broken there, either Kubernetes was in trouble, and I wouldn't bet on it, or we would have actually a problem with our setup. So in this case, what we see is simply saying, okay, we knew we're already on version 1, so Kubernetes didn't do anything. There was no change, so to speak. It's good. It went through. Now, can we actually do a rollout of a version 2, which for the purpose of this demo is a version that is supposed to work. So the service, it's exactly the same, it's responding the same, and it won't actually break, in theory, it shouldn't break the service that users are talking to, because service 2 is actually sound and working fine. So we all see that the pods have been flipped, and now we're talking to version 2, and we see those things. But already, what's interesting here, while we checked for 500, we could argue we broke users' promises, because we reset the value. So already, either we decide that our chaos experiment needs to account for that and say that's part of our SLO or SLA, we promise a value that is incremented, not going back in time, right? So you could argue that's a broken thing, even though all services have been happily switched over. But for the purpose here, we're not going to deal with that. But that's a question you would ask yourself, and maybe you wouldn't have if you didn't do, a chaos experiment. Now let's go for a service. I'm going fast here just because I want to showcase that's not very interesting. It's the same experiment with a variety of images that I pre-canned that do something I wanted for the demo. On that version 3, it's the same service, but now the else probe is going to return an error immediately. So what we see here, and we're going to be able to see that here, I think, is we've got 2 pods, and we see version 3, that's good. But we'll see we were reverted through the rollbacks to version 1, and normally we shouldn't actually go to version 3 because Kubernetes won't allow it. Because the probe is saying I'm not in a good position, I can't allow you to actually go through. That's good. At least we know, now we have evidence that Kubernetes does the right thing if you've set up your else probe and readiness probe accordingly. Now, what if, and that's the one that is interesting because so far you've seen only green, so you're like, oh, fake demo, fake data. Right, so what if we now release a version that else probe is going to be fine, but it's a little slower? So when service 1 talks to it, service 2 is too slow to respond. What's going to happen? So in theory, we should see, version 4 has been flipped here. It should come back in a minute. Yep. We've switched to server 4, and we see internal server error purely because my service 1 can't deal with it. I have absolutely no error check for that, so it breaks. So at least we know, now we do have evidence that when we release a slower version of service 2, we've actually broken our promise to our users. Even though I'm sure your test would say, it's all fine. I mean, there was nothing broken of service 2. It was working, right? It did respond, slow, but that's fine. So here, with chaos engineering, you simply looked at the system overall, and you decided to say, okay, how am I impacting my users throughout? Instead of looking at just a discrete block. And maybe through some testing, some various variant of testing, you would have looked at that. But I like the approach of chaos engineering and saying, I've got a question. I have no idea what I'm going to actually find out, but I'm going to ask anyway. So at that stage, that's good. You've experimented that, and we roll back, and service is fine. So at least we've proved as well rollback does work when things, things matter. And at that stage, we are back in system. So that's pretty good because we've covered, with a very simple experiment, we've covered quite a few scenarios. We proved that we can roll out the same version, no impact. We can prove we can roll out a new version that works, sort of no, depending on how we look at it, either no impact or actually proper impact because we resetted the value. In that case, you could argue then maybe you need some state and that sort of thing, but that's another discussion. Version 3, when the probe says, I'm not healthy, fine, you don't change anything. And version 4 is functioning, but too slow, doesn't actually work within the boundaries of our expectations, and we broke our promise. So that's pretty good because you already have 4 results. So what can we do with that? Well, at that stage, what we can do is create a report, if I can find the command, obviously in my history. There you go. So what, in theory, we should be able to do is generate a report from that. We're going to generate, it doesn't really matter, don't remember the command, it's terrible. And that's because it's an old version as well. All right, so we've generated a report from those logs, and what we have here is a PDF report could generate HTML that basically tells you how you dealt. So I'm not going to go through those diagrams because it doesn't really matter for now. But what's interesting is we do see, if I come back to, this one, the first version, we see we didn't impact our users. The counter that we probed, we collected, generated something gradually, okay? And we can see that, and we can see we didn't actually change. If you know a bit of Kubernetes, basically that's it's all good. Now we've got to the other one where we simply change version working, we see the drop, right? So that's interesting because you could really argue, am I doing right when that happens? Am I actually breaking my system and my users? All good. This one is another one that is version 3, where remember the else probe was, not happy. We didn't change anything. Fine. And it's interesting because in this one, if you know again, when you see that thing here, it really Kubernetes tells you, I tried to actually roll out, but I couldn't. I tried to switch, but I couldn't. So I ended up, not doing it. That's interesting to look at if you have monitoring tool, by the way. And the final one is obviously the one where, we remember it was too slow. So we see at some point we don't actually get a new value because we can't. So through very, very simple experiments, you've learned a lot about your system and simple things like rolling out a new version. And while I was doing the demo, I realized I learned a lot about rolling out things on Kubernetes I didn't know about. I read them on books. I actually saw the documentation. We'll finish her. Yes. I don't know. But what's interesting here is trying to really think about, I think I know. When you say to your colleague, I know what's going to happen. The verb here is actually, I assume. My whole experience, or I've done that manually somehow, is telling me this is going to happen. But do you have any proof for that? Do you have evidence? Or think the other way. Sometimes you know something is broken, and you want to actually achieve something or change make sure that it's changed. And you want to go to talk to your manager, have data for that. That's going to be more helpful than, I think it's broken. So that's a sort of thing you want to do with chaos engineering. Now, before the talk is called From One to Many. So far, I've done everything on my own, on my laptop and everything. It doesn't have to be. If you look at it here, while we ran actually those experiments, we talked to Slack. So you could already have Slack notification for your team visibility. What's interesting is, hopefully, I sent traces. So for example, for the one that was broken, I sent traces as I run Chaos Toolkit. So if you have the right header and think that trace that you're running from Chaos Engineering, you can decide to have a different behavior within your application or, alerting. You could decide not to actually page everyone when you know it's a Chaos Engineering experiment that has broken something, right? So really the idea here is to say, from one to many, not just many experiments, but many as I'm not running that on my own. There is no one chaos engineering in your organization. You're all chaos engineering because you all care for reliability, resiliency. What matters is that you are visible when you're doing it. That really is important. So that's the sort of thing that Chaos Toolkit, the open source tool, actually will provide you. It gives you a protocol to define your chaos engineering experiment, but it also allows you to talk to the rest of the crowd. That's quite interesting and that's quite powerful. Just one thing here, and you'll notice, and not in this one, unfortunately, but there was one where it went from not working to working to not working, which shows as well how the rollout happens and how actually Kubernetes switch from one service to the other from a network perspective. So you learn, again, a lot by doing. So that sort of thing, and when things work fine, it's all good, and it's basically all good. All the calls that you make in the background to the system, show that they respond very quickly. So that's really good. Now, again, like I said, I run that on my machine. Probably you would want to run that in your CI/CD. Although, don't necessarily run that, tie your chaos engineering to your deployment. Run that, orthogonally. Sometimes you want to roll out something and you want to run some aspect of chaos engineering, but you should always have chaos engineering that runs continuously, constantly. Because the prime is doing with rollout is your system lives between your deployments. It evolves, right? So keep changing the system as you run. So one way of doing that with Chaos Toolkit would be to fully, where is it? Yep, I'm going to that now. Again, sorry, I need to find the command. Yeah, that would be one. You can create a kube job, a cron job or whatever, something as simple as that. And I'm hopeful this is going to work. Right, so we see that we've got a job now. And that job runs the exact command I ran on the console and tries to create service 3. We remember that's the unhealthy one. So normally this one here shouldn't change. And that shows us basically how you automate that. So we went from doing things manually, not even actually thinking about doing them. We know, don't we? To encoding through a protocol, the experiment of a chaos engineering experiment, saying we're going to change that, we're going to collect that data because that's the one that matters to us to make sense of what we're doing, and we're going to see if we deviated when we did it, right? Toward the end, where we now automate that with kubejob, but however you want to run them, create a Docker image, and that runs. And to the way that I run on my own, to the fact that I can actually talk to everyone through, Jaeger, Prometheus, what have you, that sort of thing. You can send logs to your cloud, your logs provider, whatever, but be visible about it. The Chaos Toolkit is a platform in a sense where it integrates nicely with what you have instead of running in parallel. So chaos engineering should be really about that. So next time you think about chaos engineering, don't worry if you use words like breaking or, breaking basically, or killing machines or killing nodes, even though it's a little weird because it's a bit, dangerous. But the idea is you really think that you need to be visible. You need to talk to the whole team. You need to be part of the general pipeline of healthiness and resiliency and reliability. And at that stage, I think that's going to be all. I don't want to go a little too far down the road because there are plenty of other things on the Chaos Toolkit, but I would take a long way out of that. So, yeah, I went fast because I really wanted to show you all starting from nothing to all the way to actually having the experiment running and seeing, all the various experiments. But take some time, try to join the Chaos Toolkit, Slack, or simply read the docs, and hopefully that will make more sense if I went too fast. Yeah, I think I'm good. I wanted to go fast so that you have time if you wanted to ask questions about chaos engineering in general, not necessarily this demo, if you had something to ask about. So for that, I should say thank you for attending and following. And don't hesitate if you have any questions. I'd be happy to take them. Yes? Well, full disclaimer, I wrote the Chaos Toolkit, so I'm going to say yes. It's the best tool. No, it's a different tool. More tools that you see out there are about fault injection, and they are necessary. Chaos Toolkit doesn't do the fault injection itself. It's actually using that. It orchestrates those tools to inject fault and collect data as it is. So the Chaos Toolkit is going to be the one giving you the protocol for that, an experiment that you can share, but it really depends how you want to see it. For example, if you use Istio has a fault injection, API. You can talk to that, but you can use the Chaos Toolkit to automate that. It's a different approach. Anyone else? No? Well, thank you very much, and have a good day.